This conference will now be recorded.
Hey guys, so today we'll get started with the session called Think as a Developer. Okay, I was telling you at the beginning, when we go and do all these analysis and then talk to developers and say that there is a problem with your application, the transactions are taking high response time, or there's a memory problem, and the reason for that is, say, a class, a method is having a problem, or object is having a leak, right? When even in general, when we go and raise a defect for a response time problem, we get a lot of questions from the development team, right? It's not going to be that easy to convince them. Now we are going to talk and pinpoint problem with the code and method and object. If you are not comfortable with these terminologies, if you don't know how this actually looks like in a real world, right? You would be never be having confidence to go and explain them the problem, and then they're accepting the problem as well. Okay, so for all these practical reason, it is very important for you to get some basics of the Java and JVM. Okay, we are not going to create any applications, develop any programs in the large scale, right? But this is more in terms of you breaking that what to say that barrier. Okay, so to start with, right? You might have seen these words: JDK, JVM, JRE. Uh, Even for Jmeter to work, you need Java in the machine, correct? Um, Manoj is saying a session started. Is it started, Manoj? Hope you, I'm audible. If it is not, then please maybe you can log off and log in.
And Satish, it is also
very slow, very small. Satish,
Sorry.
your screen showing very small screen.
Yeah, for me also it's the same.
No, you have to go on top where it shows everyone and choose hide everyone, and you can see the presentation screen.
Yeah, you can go and hide everyone. This option.
Yeah. And Satish, also this is recorded one, right? Means it will be recorded now.
Yeah. Every day it will get recorded. Correct.
Okay, thank you.
Yeah. So even for your Jmeter, most of the softwares require Java, right? So Java, mostly you have already installed Java. And when you install Java, right, there are two things. One, if you wanted to develop programs, compile and deploy, you need the entire JDK, Java Development Kit. Okay. When you want to just run the application, for example, if you wanted to use only Jmeter in your machine, which Jmeter is a Java application. Okay, Jmeter is developed on top of Java. Okay, so for to use your Jmeter, or say you're just going to deploy the WAR file in a Tomcat, your testing environment, your production environment, right? Maybe it is not required to have an entire Java development kit. You just need a JRE. Okay, so these are all JDK is a superset. Okay, and in JDK you'll have JRE plus compilers, debuggers, etc. JRE plus these compilers, debuggers together is what we call it as a JDK, which is required for developing, compiling, and creating an application. Okay, JRE is Java runtime environment. To run a Java application, you need a JRE. Okay, and JRE will contain the JVM, Java Virtual Machine, in which your code will get executed. Okay, so JRE inside will have a JVM and some of the class libraries. It is nothing but if we go to a directory where Java is installed, right? You would be able to easily differentiate all these things. We go to Java and then say there's a JDK. Okay, if I go inside JDK, you will have JRE Okay, and then you will have bin. Okay, and if you go inside the bin, you will have your compiler Java C, and you will also have other JConsole, JMap, JStat. All the debugging utilities will be there inside your bin. Okay, so JDK is a combination of some compilers, debuggers, plus JRE. And if you go to JRE, and if you go to library, okay, JRE, and if you go to bin, go to server, you will see the jvm.dll. Okay, so since it's a Windows machine, you will have a jvm.dll. If it is a Linux, you will have a jvm dot probably sh or the extension jvm very specific to the Linux OS. Okay, otherwise your JDK will comprise of JRE plus some other compilers and debuggers. That's how it is. Okay, end of the day, it's a kind of a set of folders and files. And for our practice, you install the entire JDK. Okay, if you go to Oracle website, you can download the Java 8 or Java 11. Okay, and install it. And once you install it, right, go to command prompt and then check Java-version. Okay, so when you type in Java_version or Java-version, if it is going to reply saying that the Java version is 1.8 or 1.11, then which means your Java is installed properly. Or in case if it is not showing, you've installed it, but if it is not showing the version in the command prompt, go to the environment variables. Okay, and then here in the system variables, you should have something called Java Om. Okay, so check that whether it is already configured or not. While you do installation, normally this will get added automatically. Okay, in case if it is not there, you can go and create a new entry here, put Java and then Java Om, and for a Java you have to specify until /bin, JDK/bin. For Java Om, it will be till JDK. Okay, so Java Om is where is your Om directory is. Om directory is JDK. Java is wherever the Java.exe is present, right? If you go to JDK, if you go to bin, you will see Java.exe here. This path is what you have to give it in your under Java. Okay. Additionally, if you go to the path variable, there will be something called path. Okay. Go to path, and in the path also, you will have this Java.exe path /bin. Okay. Don't put /bin/. Okay. This might not work. Okay. Just type in this. Once it is done, close it, and again you can go to the command prompt, close the command prompt. The old command prompt will not pick the changes. Always when you make a changes to an environmental variable, close the prompt and then again go to the command prompt and type in Java-version. You should get your version in the response. Okay, so just the very basic validation, you can do it later tomorrow. Okay, whenever you are trying to set up all these things. Okay, now so we have seen JDK. Inside JDK you have Java runtime environment, and inside JRE you are going to have a JVM, right? Now when you look at the life cycle of your application, right? You create your program. Okay, any program, say for example an addition program. Okay, A plus B is equal to C. Very simple algorithm or simple addition program. Okay, so you need to do a addition of two numbers and then get an output. So you would have something called a plus b is equal to c, right? And then you're going to save it. So when you write a code and save it, you will save it as a .java. Okay. And then when it is getting compiled, it becomes .class. So a compiled version of Java is going to be your .class. So if you're going to create some 10 programs, one for addition, one for subtraction, division, right, some other computation, right, for every .java, after compilation, you will have a .class. Okay, class file is nothing but a compiled version of your Java program. Now, once these programs are compiled, when you do an execution, okay, or when you start your server, it will get loaded into the JVM, all your classes, everything, and JVM will execute that classes, the code, and then it will provide an output. So the JVM Java virtual machine is going to be the core component, which is going to take care of your executing of your code. Okay. And within JVM as an architecture, there are two main components. One is your memory. Next is going to be your execution. Though there are several other components, like you have something called class loader, which is just for loading all the classes that is part of your application, right? Nothing more than that. We would need to know what is called class loader. Class loader, as the name suggests, it's going to load all the classes that are part of your application. That's it. Okay. The JVM memory is going to be a huge component, very important component. Okay. So we all know in a machine, say in my laptop, I'm going to have a RAM. Right? RAM can be 4 GB, 8 GB, 12 GB, 16 GB, whatever it is. And for my application to run, application also will require a memory. So which means from your 8 GB RAM of your laptop, some portion of that has to get assigned to this application. Correct? So within JVM memory, you have multiple subdivision. You have something called metaspace, heap, stack, PC register, and native method stack. Okay. Again, out of these 5 components, the most important component is going to be your heap, followed by the stack. Okay. Why it is very important? One, say for an addition program, you declare some variables, right? Say you will declare A as a integer, B as an integer, C as an integer. You might declare some strings, some character, some array. So in a program, you go and declare these various data types, right? Because to store the input or to store the intermediate results, you need these variables. Correct. Now, this heap and stack are going to store the majority of those that you declare in a program. Okay. To say precisely, your stack is going to store all your small data types, integers, boolean, character, all small variables will get stored in your stack memory. Okay, all the your strings, array, objects, all these things will get stored in your heap memory. Okay, so there will be one huge memory called heap. Okay, and whenever a string or an array or an object is getting created, it will go and sit inside the heap. So which means you need to configure what heap you need. Out of your 8 GB RAM, you have to say I need 2 GB or a 3 GB or a 4 GB. Okay, so the configuration is something as an architect or a performance engineer, he has to do it. We have to monitor the heap. There will be problems with respect to the way objects are getting created and destroyed. So we have to do some good analysis, leak analysis. If there are leaks, you have to constantly monitor. There are problems during a load test or in production, you take heap dump. So a lot of things will happen in heap for the heap by the architect or your performance engineer. So that's why the heap is very important component. The majority of the variables that you declare will go and sit inside the heap. All the small methods, integers, we call it as something called primitive. I'll talk about primitive, non-primitive and all later. Okay. So for you to keep it very simple, the small variables will go into the your stack, and all your arrays and strings and objects will go into your heap. Okay, we will learn more about this. Is very important. These connection between stack and heap is very important when it comes to garbage collection, when it comes to memory leak. These are very important. So we will go into this deeper when we go for your memory related topics. Okay. Now at high level, your JV memory will ask 5 components. Heap, stack are the important top 2 components within the JV memory. Other 3 are not. Everything is important anyway, but more from our engineering perspective, we don't go and really touch those. Okay, PC register, we never do anything at all. Okay, it is just a very small memory space which will keep. It's kind of a logger which will keep track of what lines of code is getting executed by each thread. It's a registry. Okay, you can think that as a registry. Okay, so we don't do anything at all. We don't configure what memory is required for PC register. We will not monitor it. There are nothing going to go wrong with these things. Same way with the native method stack as well. Okay, as the name says, native. Okay, when your Java application is going to interact with your OS components for any IO activity, or if it is going to call some Windows program, right? For such interaction, for such communication, if any variables are used, that alone will go and sit inside the native method stack. Again, we won't monitor. We are not going to allocate any memory to it. We'll not even know there's something called this going to exist. We will constantly work around the heap only. Even stack, right? Stack also, we don't really go and configure the memory and all to stacks. Okay, we will just leave it as a default. Heap is the only one we will be worried about. There will be problems. We will configure it. We will tune it. We will benchmark it. We'll do everything around the heap area. Okay, so in your JVM, in your code, in your Java code, depending upon what variables you declare, those will go inside your heap or stack. Okay, that's one of the component, memory. Now the other component is going to be your execution component. So the code has to get executed, right? So the classes are loaded, and then it has to execute the code depending upon, say, a user might do a login or a registration. Right? Depending upon that, the code has to get executed. Okay, so the execution engine is going to take care of the actual execution of your code. Okay, when I say code, you compile the code. When you create a program, you compile a code, right? and this code has to be converted into a mission understandable code. That will be taken care by your execution engine. Okay, there's something called interpreter, which is going to convert your compiled Java program to a mission understandable code, which means in Windows, it will convert into a Windows understandable code. If it is going to be Linux, it will convert when the JVM starts, when the classes are loaded, when there is going to be action going to happen, then your JVM, your execution engine, will convert the code into a mission understandable code. Okay, that is again a very important functionality of an execution engine interpreter. But there are interpreter kind of a component available in execution engine. There's something called hotspot profiler, JIT compiler. All these things are all going to be core component of the execution engine. Okay, the hotspot profiler will keep noting the frequently accessed method or a class file, so that for efficient execution, it can actually pre-compile and then keep it ready for an execution. These things will be taken care by the hotspot profiler and JIT compiler. But we don't have any role. We as a performance engineer or we as an architect will not have any role on defining the functionality of the profiler, hotspot profiler, or JIT compiler. Is all going to be taken care by the JVM. Garbage collection is one of the component in your execution engine. Okay, the garbage collector is going to do the cleanup work. Okay, see the JVM memory, as I said the other day, it's not going to be infinite, right? Your laptop is having a 8 GB RAM. In that, from 8 GB RAM, it will allocate a certain memory to a heap, stack, other components. So which means there's always going to be a finite boundary. Okay, so which means when application is going to be used, there are multiple transactions that is going to happen, and there are going to be multiple objects that are going to get created. So it will keep on growing, right? It is not going to have a endless boundary. It is going to have a boundary, a finite number, 6 GB or 8 GB. Okay, so which means there has to be a person, or there has to be a component in your JVM which has to keep deleting the unwanted objects. Okay, that is going to be the called garbage collector, which is going to be part of the execution engine. And this garbage collector is something of interest to our engineering, because you may have to probably choose between collectors sometimes, and if you'll monitor the garbage collection activity, number of major GC, number of minor GC, how much time it is taking for a GC to complete, the GC time, GC CPU, all these things we have to configure, because though GC cannot be avoided, it's very, very required, because it has to do a cleanup work. But it is also going to have a CPU impact when your garbage collection is going to run. That's a nature. We cannot be without garbage collector from a memory aspect. But if GC are going to happen very frequently, or if the GC is going to take a lot of time, then it is going to impact your overall application. Okay, so the GC is something we'll learn in detail later. But in the execution engine, the GC is a component which we will be doing the customization in terms of choosing a collector, applying flags, monitoring the GC continuously. All these are the typical activities of a performance engineer from a garbage collection perspective. Okay, fine. Now, these are the basic understanding you should have it from a JVM perspective. We'll go in detail when we go into memory topic later next week, right? We'll go into detail about stack, heap. We will simulate some problem with respect to stack. try to understand this little more better, right? All these things we'll do it in the when we go into a memory related session next week. Okay. Now what we'll do is we'll spend some time on understanding the skeleton of your Java program. Okay. Now, see, again, our intention is not to be an expert in Java, not to go and read Java more from a book perspective, right? If you go and take any book, any Java book, okay, any course, Java course, it will go through a sequence, some kind of a sequence, right? It will explain about OOPS concept, and then it will give you data structures, condition statements. That's how any courses will be structured for a Java. Okay. Now, at this point of your career, right? Few people are 2 years experience, 4 year experience, 8 year experience. So you're already into the some level of experience in your career, right? Now, the easy way of learning is to start writing some programs, create some programs, and then understand why it is written. That will keep you motivated in creating programs, understanding the programs, rather than going into a book way of a concepts theory and then getting into a hands-on. Okay, now let's try to understand this the skeleton of any Java program. Okay, if you guys are very familiar with LoadRunner or Jmeter, right? Every LoadRunner script will have init, action, end. It will have parameter file. You will have start transaction, end transactions, think time. All these are going to be skeleton of any LoadRunner script, right? Similarly, in Jmeter also, you will have thread groups, transaction controller, throughput controller. You will have config elements where you can go and add these results tree, and then that are going to be forwarded to send data to the InfluxDB. All are various components of your Jmeter. Okay. Now, similarly, any Java program, it is going to have this as part of the project. Okay. It is going to have, I said, right, already you create programs, which is going to be called as a .java program. Any program that you write and then save it, it is going to get saved as a .java. Okay. And when you compile it, it becomes a class. Okay. And any Java program, right, even any program you take it, right, it will have two things. It will have actual computation, A plus B is equal to C, A minus B is equal to D, some addition, subtraction. The actual computation will be there. And then you'll also have some declarations, variable declaration, right? So for A plus B is equal to C, you have to declare A as an integer, B as an integer, C as an integer. And then your program might require to declare strings, arrays, right? All these things are going to be there. So typically, all the computations will be part of something called method. Okay. So a class file might have one or more methods, one or more computations. Say addition, there will be a method. Subtraction, there will be a method. Multiplication, there will be a method. Okay. So there are going to be more than one or more methods in a class file. Method is nothing but a computation. The lines of code which is going to do some computation on the input. And as I said, variables are going to get declared. In the variables, there are two types of data type in Java: primitive and non-primitive. All small variables like integer, character, boolean are called as primitive. I already told you these integer, boolean, everything will go and get stored in the stack. And there are going to be non-primitive like objects, strings, arrays. All these things will be part of your non-primitive. Any program will have a class, will have a program. Okay, a compiled version of that is going to be a class. Inside a Java program, you're going to have primitive and non-primitive data types declared, and you're going to have the methods, which is going to actually have a code for your computation. That's how the skeleton is going to be for any Java project if you take it. Okay, it can be small, medium, very huge enterprise, but these are the basic building blocks. Okay, at least for your understanding, this is how we have to understand to begin with. Okay, we can keep adding a lot more complexity. With complexity, there is going to be a lot of confusion. It's not required. Our intention is totally different here from my engineering perspective. From that perspective, whatever I explain, whatever definition I give, whatever examples I give, it might not be perfect. Okay, but it is more for us to remember things. Okay, now let's come to the next thing called object. Okay, that's very always a confusing topic. There are a lot of definition available in lot many places. Object are instance or a duplicate of a class file. That's what people tell, right? Let me explain you with an example so that you won't forget this. So we all use Amazon.com, correct? For our e-commerce, as an e-commerce application to purchase things, we use Amazon.com. Okay, and say you access Amazon.com, and then you look for a laptop. Okay, a Dell laptop, and you give your specification as it should be 18-inch, it should have 8 GB RAM, it should have this many your disk space, all these things, right? Then you go and search it. Okay, and then you might get a 1 or 2 laptop as a recommendation. Now, I'm in some other part of the world. I'll be using the same website. Maybe I need a mobile. Okay, maybe a Samsung or any mobile. Okay, for me then it will go and provide me the recommendation of saying that these are the various devices available. Now, if I want to check the price for that particular mobile, okay, I'll be going and check for the price calculation, right? Click on estimates. Similarly, you as well for a laptop, you also will be doing the same thing to get an estimate. Okay, so for both of us, a pricing estimate is required. Okay, when you click on that pricing estimate button, a request will be fired to a backend. Okay, and for me, a request will be received. For you also, a request will be received. Okay, and within your application, there are going to be multiple services, and in each service, there are going to be 2 or 3 class files, and then each class file will have these methods and data declared. Right? So for checking the pricing, it will come to your application server, and then there will be one program called, say, price calculator. Okay, there is a program called price calculator.java. Now, what will happen is, for you, an instance of the class file will get loaded into the JVM. Okay, an object of a price calculator class file will get loaded into your JVM. Similarly, a separate object will be created for me as well for a mobile. Okay, so there will be only one class file, but whoever is going to call that, whenever that is going to get called, object will be getting created, a duplicate of the class will be getting created, and it will be accessed. Once the work is completed, that will get deleted from the heap. That's how the JVM works. Okay, so which means for you, the product would be laptop, and then quantity would be, say, 1, and model is going to be Dell. For me, mobile is a product, and model is going to be, say, Samsung, and then quantity as, say, 2. Okay, so runtime object for this pricing calculator will be created, and for my object, in my object, the properties are going to be the quantity is 2, product is mobile, model is say Samsung 20 or 18 or whatever it is. For you, it is going to be a laptop, Dell, and quantity is 1. Okay, so the object A, which is created for you, will store this information, will handle your execution of pricing calculator, and then it will return the data for you. For me, for mobile, the same thing will happen. Okay, the code will get executed for my requirement, and then the data will be returned back to the UI. After that, sometime that object will get deleted. All these things are part of the GC, which we will learn later. But for now, for you to understand the object is a duplicate or an instance of a class file. Okay, and there are going to be a number of objects that will be created and destroyed during a runtime. Okay, so class, object, method, and data types, we have seen it. Let me go to the Eclipse and probably show some of these programs today, right? To see the structure of the project. Okay. Now, if I go to, yeah, go ahead.
Yeah, sorry.
Go ahead. No problem.
Yeah.
Go ahead.
So Satish, regarding this class and objects, right? So as you mentioned, the pricing logic or the code, right? It will be the one, right? And as per the requirement of end user, there will be the different objects will be created, right? So is that understanding right?
Correct. You're right. You're right.
Okay, but just question, curious to understand because the logic of calculating, as you mentioned, right, for phone and the laptop, it will be the different, right? Because the prices and the configuration wise, right? If suppose I'm instead of buying a phone, I'm buying shoes and laptop, right? So how those will be managed in the class, Miss?
Correct. So I'll for this exactly thing, right? I have a program. I'll show you tomorrow and explain you. See, within the class file, right? For example, if I go to this price calculator program, you will have the declaration done for. So if you go to the price.java, okay, and we go to the price. Where it is? Price cart.java. Okay, so there's something called. So when the price calculator is called during the runtime, right? There's something called product. There's something called quantity. Okay, so from a UI, you will be selecting a laptop and you will be selecting a quantity as one. For me, it is going to be mobile and quantity is going to be 2. Okay, so when a object is going to get created, okay, and which is going to take care of your request, right? The product and quantity will be assigned, okay, as per your request. Okay, for me, these are variables, right? It's not going to be constant. Here in the program, I have just hard coded, but this will come from the request. Okay, from the request, it will come as product as mobile and then quantity as 2. Okay, and the object which is going to get created runtime, which is going to handle your request, right? For that, the variables are going to be whatever that is going to come from the UI, right? Mobile or laptop or quantities of 1 or 2. So it will be dynamically handled during a runtime. Okay, so when an object is getting created during a runtime for your request, that will hold the data for you, and it will be only accessible for you, you alone, right? When I say you, for that particular thread alone. Okay, and once that activity is completed, all these things will get wiped out, and the object will also get deleted from the your heap. Okay, so in your program, there won't be anything called mobile or quantity. It will be coming from UI, but the price for that, probably it might make a call to a database saying that for Android, Samsung, this version, there will be a price, right? So it will make a call to a database, and database will return the price for that particular model. Same for laptop. So the dynamic data is going to be available within your database. See, there will be some tax depending upon which country, which state. Tax might be applicable for few products. Discounts will be applicable for few products. So the tax, discount, offers, all these things will come from the your database. the actual program will have a logic to apply these tax and discounts and offers, and then it will return back that response back to you. Similarly, for me as well, who request for a mobile, it will come to the same program. Object of this will get loaded, and then it will handle the input whatever I gave it for mobile and quantity. It will go and fetch data from a database for that particular product with tax, with the discount, with offers, everything, and it is going to return back the output to my UI. So that's how it is going to be completely dynamic in nature.
Okay, got it. Thanks.
Yeah. Okay. Now, if we go to our e-library application, right? People who are interested in getting the e-library Java code as well in your Eclipse, you can download the Eclipse from your website, or it is available in the drive also. Okay. Drive link. Let me paste a drive link to you. I have given access to this drive to everybody today who have given me your email ID. Okay. But the drive link which I gave it in the WhatsApp, I think it's different. So there's a little bit of confusion over it. Okay, I've given access to this folder, this entire folder. Okay, I'll ping you this drive path here. Okay, you can use it for your getting whatever you want. Okay, so Eclipse will be there in this drive as well, or you can also download it from the internet. Okay. If you come down, Eclipse being a huge file, I don't know whether it is there or not, or even you can download it directly from the internet itself, right? That's more easy. Okay, better get it from the Eclipse site. Okay,
Satish,
and then
when I click on that link which is sent, right? So it is asking for you need access viewer, commenter, and editor. So which one should I select? Editor?
Coming in, sorry.
No, you sent a link, right, for this drive.
Correct.
So when I clicked on that link, it's asking me to get an access request for an access as a viewer, commenter, or editor. So shall I select editor and?
No. You give a viewer only, but I have given you access. What is your name? Sorry. Manthan. I gave. Let me quickly check. So what is your email ID?
Manthan Bhayani. Okay, sorry, got it. I log in from different laptops, so maybe
okay. Yeah.
sorry.
Sure, no problem. Okay, so you
Satish,
download the please.
I have access issues similar. I just
okay, what is your
Prasad?
Okay, 1 second. Yeah, tell me, Prasad.
Prasad in Konda. PRA? It's not Hari Prasad. It's not a Hari Prasad. It's Prasad.
Okay, Prasad. Tell me, Prasad.
Nakonda. ENAKONDA. I will ping in the chat.
Yeah. Okay. I think you, if you ping me.
I also did ping in the chat my email ID just now. If you can provide.
Okay.
I've requested.
Sure.
Yeah.
Okay. 1 second. Okay, let's do one thing. Whoever has not got the access, just again ping me in the WhatsApp also, so that I will not miss it out. So Prasad, this I will give it right away.
Oh, even for me at the other email ID.
Okay, sure. Okay, other one is
the first one on the top. Thank you.
Okay.
Also, when can we expect the recordings? Because I'm missing some
No,
part of
recordings will
this.
be every day. Recording will be available the next day immediately. So yesterday recording will be there. It's already uploaded.
We don't
That's how
have
it
the
works.
link. Maybe if you can share.
No, are you in the WhatsApp? You are in the WhatsApp group, right?
Yeah, I'm in the WhatsApp group, but I didn't see that.
No, it is there. There is an. You go to the group, and today morning around 10:30, I'll again ping that YouTube link as well. There are two groups. I don't know which group you are, but
Yeah,
I'll place that.
I can see that. Sorry.
Yes,
And
yes,
today's
yes.
recording also, I missed some of the class. So when can I expect it tonight?
Today's will be available tomorrow before 12 noon.
Okay.
Maximum by 12 noon.
Sure. Thank you.
Okay. Fine. Jayapal, I can see your email ID. Okay, I'll give it to you as well. Okay. And still, if you guys have any issue with the drive, please let me know. Okay. I'll sort it out as soon as possible tomorrow.
Okay.
Yes. Fine, guys. We'll stop pause it here. Okay, there are a few people who couldn't able to join, so we'll finish it a little early today. Okay, and we'll continue with few programs, hands-on programs tomorrow. Okay, let's go and create few Java programs. Our class will be looking like how to create multiple class files, how to call one class file from another class file, how to make a DB connection. So we'll spend good amount of time in doing some hands-on in these whatever I said, and then we'll go and compile, execute, and we'll create some jars. We'll also see how to create a WAR file for a web application, right? When whatever developer will do, let's try to do it in a very minified way, right? Not in a large scale, but at least a very subset of that, right? For us to understand the entire thing that a developer will do. If you also know what they are going to do, how they are going to do, then these things will not be a black box for you at all. Okay, that is the actual intention of doing this exercise. Okay, fine, guys. Yeah, we'll meet you tomorrow then.
Okay. Thank you, Satish.
Yeah, thank you.
Thanks.
Yeah, thanks,
Bye
Satish.
bye. Bye bye, guys. Thanks.
Yeah, bye bye.